So, hello. We are starting a bit late today due to some technical issues with computer from Mentor Victor that I think he just went to Cupertino, California, man. You're showing the Apple building behind of you.
Yeah, it's part of the latest update from macOS.
How are you, Mentor Victor?
Good, finally working. I don't know. It's just sometimes technology breaks and you just don't know what to do. And
And you are
sometimes a
using
reboot will.
your work computer on this talk?
No, this is my personal computer.
Okay.
It's my personal computer.
I thought you were breaking something. Where you develop?
No.
You just install whatever. Okay, so.
No, it's my personal one.
Okay, so before we start, first introduction. We are here today, Mentor Victor, Javier Macho. Hi, Javier. How are you?
Hello, everyone.
How are you?
Well, I'm fine. It's close to summer here in Spain, so
pretty hot in Madrid.
Yes.
Good. Alejandro, how are you?
Hello, everyone. I'm good. And you? How are you?
Good. A little bit late. I don't like to be not on time, but sometimes things happen, and that's life. Devanjan, how are you?
Yeah, I'm fine.
Very good. You are a little bit more than 8:30 in the night in India.
Yeah.
PM.
Yes.
Good. So, guys, today's agenda, and for the people that from the community that is looking at us and will look later, like that Madhab Majumdar that is already on the streaming. So today's agenda is that we have this year a new piece of technology in the Liquid Galaxy project. We call it the robotics server. Basically, it's a Docker server that is on the main Liquid Galaxy rig network, and then here the contributors developing this year applications not with AI specifically, but with robotics things. You guys need more software to be installed than the usual requirements, and instead of installing this on a specific machine, you are going to install this on the Docker servers. And today's Victor presentation is going to be about this, how to use Docker for our server for installing your application. So it's going to be a introductory presentation about Docker. But I want to listen from you all for 30 seconds. What is your approach now that we are in the third day of GSoC this year? What is your approach? What are going to be your uses of this Docker system for your projects? All of three you share that are robotics related projects, visualization of course. So start from the end. Devanjan, what are you going to do with this server? What is the software you're going to install?
Okay, so I'm developing a project through which you can simulate any robot in Gazebo and then stream that to the Liquid Galaxy rig. So I need this Docker images so that I will develop these things in a PC that has Ubuntu 2022 and ROS to Humble. But as we know, different versions of Ubuntu requires different versions of ROS and Gazebo. So I have to build this in Docker so that it can work across every device simultaneously and seamlessly.
Good. Alejandro.
Well, I'm new in this software with Docker. I've never used it before, but I think I'll use it for the main server of my project because it's a project where you need to share information from the robot and put the information on the Liquid Galaxy screens. So for the main server, I think I will need to use Docker, and also maybe for the simulation environment with Gazebo and ROS, maybe I'll need to use that in Docker also.
You say maybe at this time you have to know a little bit more, but we are just starting. But you have to press because
yes.
We are, GSoC takes a lot to start, but when it starts, it goes so fast. So, Javier, what is your thing? What are you gonna use
Well,
the server
my
for?
project is about controlling robots. So I need ROS to control robots, and also I need an Ubuntu Classic server to run fast downward to generate the action plan for the robot. So the idea is to build a server with some little services inside of it, like the LLM to process the information, like the ROS to send the instructions to the robot, and lastly the planner to decide what the set of actions that the robot needs to perform.
What version of ROS you are gonna use?
ROS 2, I guess.
I suppose, but you didn't say ROS 2, and there is still people using ROS 1 or many legacy applications on ROS 1.
Well, not me. I'm new at ROS, but I believe that I'm gonna use ROS 2. Well, it's 2.2 or ROS 2
Yeah.
only. I don't know.
Good.
But
Great, guys. So the question now is, Mentor Victor, could you please share your screen with the presentation?
Yeah. Let me see if I can do it
Oh,
fine this
we
time.
know you can do it.
Okay. Share entire screen. Does it work? Should work.
Yes.
Is it working?
Yeah, we see your
Okay.
slides. Do the
Present.
full. Yeah, perfect. Full screen.
Nice.
Perfect.
Okay.
So the
It's
question,
working.
Victor, is that guys, you three students here, contributors here, can ask questions to Mentor Victor at some point, at any point. Just raise your hand on the Meet, and then if there is something you don't understand for this presentation. And for the guys on the streaming, Ariane and MathHub and whatever other ones will come later, if you want to make a question, just wait for the end of the presentation, okay? So Victor, we are gonna mute our mics and you're gonna start the presentation.
Okay. Actually, for the questions, just please, if you can let me know, because I can't see you. I just can't see my slideshows. I only have one monitor. So yeah, just let me know. Hey,
we'll do by voice. We'll do by voice, you mean?
Okay, yeah.
Okay,
please,
so
because
Javier,
otherwise
Alejandro, and Devanjan, if there is any question, just raise your voice and ask Victor, please, I have something, okay? Okay, go.
All right. Good. So, well, welcome everybody. And yeah, sorry for being late. It's been tough afternoon for my laptop. I don't know why, but yeah, after a reboot, everything got fixed. So yeah, as you know, my name is Victor, and I am mentoring this project for Google Summer of Code. And today I'm going to talk about the basics, or what I think you should need to know about Docker. Okay, what happens? Docker is way more broad and way more complex than what I'm going to show today. What I'm going to show you today are just the initial tools that you're going to need in order to build a small project, okay? If there's anything that is not clear, there's any doubts that may arise in the future, let me know, okay? I can give you my contact information, and then we can discuss it, okay? So there's no problem if this is overwhelming, if you don't know everything on the first day, because this is quite a bunch of information, and it's a concept that is it's something that is not easy to learn, let's say, in a couple of days. But essentially, today, we're going to talk about what it actually is Docker, what purpose does it serve, and then how is Docker built, then what are the benefits of using something like Docker, which I assume that you have already imagined, so we're going to discuss them in the next slides. Then we're going to talk about what makes Docker work, or how does Docker work, or what are the required elements that make Docker a tool that's so useful. And then the Docker file. We're going to focus on the Docker file, both theoretically. I'm going to show you a very simple example. And then on the live demo, I'm going to show you a bit about what you can expect when you get in front of your computer. And then I'm going to show you my personal project in which I use Docker to streamline the portability and the development of this project. All right, so this is going to be what I'm going to cover in these minutes. First thing first, Docker, understanding Docker and containerization. Okay, so Docker is all about what we call containers, and the problem or the answer to the problem that we're going to solve is containerization. Okay, what is containerization? Is packaging applications with all the dependencies for being able, in order to be able to execute them, no matter the hardware. Okay, so the laptop or the computer. In your particular case, you have your own development computer, your own development hardware, but then there is another hardware, which is in this case the Liquid Galaxy rig, which may have another operating system, may have another set of libraries, some sorts of dependencies that may conflict with the work that you have developed in your own development computer. Okay, so Docker, the problem that Docker aims to solve is, will it work on any computer, no matter what? And this is what Docker this is the problem that Docker tries to solve. Okay, the way it works is, if you check the diagram on your right, so we've got the infrastructure, which is, as I mentioned, this could be your development server, or it could be a Liquid Galaxy rig, which is going to have in turn host operating system. You may be working on Windows, whereas the Liquid Galaxy rig may work on Linux, maybe, or on macOS, or whatever operating system. And then you can see that there is a problem here. So computer A, your computer, works on a certain set of resources, whereas the computer where you're intending to transfer your work runs under another certain set of resources. Okay, so we have a base problem here. And then Docker acts like a layer which tries to unify the differences between computer A and computer B, and in turn computer C, D, E, F, G, regardless of where you want to distribute your code. How does it do that? I'm not going to talk about that, but essentially you can think about, you have your application, you code your application, and then you have to transform it into a package. This package is going to be called a container, so that Docker, the intermediate layer between the two softwares, in this case, two computers in this case, can understand that everything that you add into that package is going to be readable regardless of where it's run from. Okay, and this is what we're going to cover later. Of course, the features and the benefits are the ones that I mentioned, right? So you ensure, by eliminating the differences between these two hardware systems, you ensure portability, so that you can nearly guarantee that what you have coded at your home for the Liquid Galaxy project will run on the Liquid Galaxy server or on the rig. Also, you can scale them. We're not going to talk about that today, but this is another use case. You can clone this application across different computers, so that in case some application goes down, it can get up again. Okay, so you can, if you're facing, for example, high demand, or you're trying to load balance different applications, you have 5 instances of the same application, you can automatically get them up or down based on demand. We're not going to talk about that. This is way more complex than what I'm saying today, but it's something that Docker may allow us to do if the situation required it. And then, of course, efficiency. So Docker is very, 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 very fast. Okay, so by enclosing everything into one container, we can power on and power off containers in at a very high speed, and then they can be very resource effective. Okay, so this is not something that may make you, let's say, use Docker if you're not concerned about efficiency, but it's definitely a great addition that for very big projects, or maybe for computers with limited resources, is definitely a great add-on, and Docker provides that. I'm going to talk about the Docker architecture. Let me grab some water. I'm recovering from a cold. So let me talk about the Docker architecture. Okay, so Docker is a complex system. I'll show you later how can we install it and what can we expect from it, let's say, as a user. But essentially, Docker has some building blocks, which we're going to call images. Okay, so an image is essentially, if you have worked with virtual machines, it's not exactly like a virtual machine, but you can think of it as the operating system, the base operating system that you would like to use. Okay, so it's true that you may be working on Windows, but for example, there was projects which may need to work only on a Linux machine, for example. Then you can download a copy of the, in this case, Ubuntu or Debian or whatever Linux distribution, so that you can use this operating system as the ground, as the, let's say, the seed for everything that you're going to build on top. Okay, so if I want my application to work on a certain operating system for whatever reason, then you can provide this operating system. Okay. In turn, let's say you, for example, want to develop, I don't know, a load balancer, okay, or a cache, because you just don't want, you only want to focus on a container which serves another purpose in a distributed system. You may want to use other Docker images that providers, companies, allow you to use. For example, you see Nginx or you see Cassandra, for example, for your databases or your load balancers. And these are going to work the same. These images are stored, you can think of it as, for example, when you want to download an application from the market, let's say you've got Google Play and then you have the App Store. Docker has the registry, okay? It's called container registry, which in turn is like an image, not store, because most of them, I would say all of them are for free, but you can just go there on the internet, connect to the website, and then you can download them, okay? So once you download them, you're going to see them inside the Docker host. So if you see on the center of the diagram, you've got Docker host. Docker host is your computer. So these images are going to end up, are going to land in your computer, and then you can use them to build your own containers, which is the last element of this equation. Containers are the packs which, using a base image, in this case Ubuntu or Oracle or Nginx, are going to host also the code that you're going to need to run your application. So if you have, for example, a ROS application, in this case, a ROS application, your code is going to have to be packaged inside a container with this base operating system, so Ubuntu or Debian or CentOS or Arch Linux or whatever, and then it's going to bundle your code. Everything enclosed and runnable by Docker, okay? Which means that then once you have your container, then you can distribute your container. How? By pushing it into a registry. So in this case, the Docker Hub. And then fast forward, so if we zoom in to how do we create our actual container, we need 3 elements, or we're going to have 3 elements or 3 stages in this workflow. First of all, we're going to need a Docker file. And a Docker file, I'm going to show you in the next slide, is like a recipe, like a kitchen recipe. You're going to let Docker know, look, I want to create an application, my Rust application, for example, which is going to sit on top of a base image, okay? And I'll show you later, okay? But you're gonna have your base image and then all your dependencies. This Docker file is going to be able to be converted into a custom image, so Docker image. And I'm going to show you later how it looks on your computer. And then this image can be used in turn to create containers, which are replicas of these images. And then what you have to do, or what you will have to do to deliver your project, is to create your Docker file, build the image, and then test that the container is working. If the container is working, you get the image, and then you can send it to Liquid Galaxy in this case. So that you can use it like that. All right, so I'll walk you through this project in a second, but I just want you to know the 3 steps, the 3 basic steps that you're going to need to make Docker, let's say, or to use Docker in your developing journey. And now let's go for the Docker file. So we talked about you have this recipe, this cooking recipe, and then all Docker files are going to start with the magic keyword from. Okay, so from is going to let Docker know what is going to be the foundation or what is going to be the ground you're going to build from. Okay, so in this case, for this particular example, someone is using Node, so they are going to create a Node application or use the Node.js official image built on top Alpine 3.16. Alpine is a very, very, very lightweight Linux distribution that may work in your case. Okay, so Alpine is so tiny that it only weighs some very tiny megabytes, and then you can use it as a very basic image. If you need your application to run on Linux, but you don't care about all sorts of, let's say, extra packages that may come with Ubuntu server, maybe because you only want Linux to be on your image, you could try and use Alpine, and that will drastically decrease the size of your image. Okay, that is something that you can use. In any case, that is your decision. Of course, you can let me know if you have any questions, but for me, I would just either go for Alpine or just go for Ubuntu. If you have some heavy, strict requirements about that, let's go for Ubuntu. Then secondly, you've got Word there. And this essentially works like a copy and paste, and I'm going to show you in the live demo. So you're going to let them know, okay, now I have my Linux file or my Linux operating system container. Now I'm going to add some files into the /app folder directory. Okay, and then copy ... means from the folder the Docker file is in. Okay, you have to have the Docker file in a certain folder. Copy everything into this particular directory. So /app inside the container, which means put my code inside the container. Okay, and then run is going to be npm install in this case, which is just going to start a new Node.js server, which is specific for this particular project. You don't have to use it if you're not going to use Node. And then cmd is just, once everything's done, you're going to have a starting command. So once my container starts working, the only thing that you're going to do, Docker, is type npm start in this case, or Python, whatever, just to start my code. Okay, so this is like the entry point, that's how we call it. So you have your Rust application. Your Rust application is going to do something. Then cmd, the command you use to run Rust, separated, comma separated in this case. And now, I don't know, Andrea, let me know if you can still see all of this. Can you see my desktop?
Yes, your desktop, no,
Yes,
we are
yes,
seeing
sir.
still your slides.
Okay, that's not what I want. Well, my desktop means like everything, right? Yeah, I'm seeing my
No,
Docker.
this is your desktop because we are no, we can see your Docker desktop.
Okay,
Docker desktop.
okay. Okay, so now what I'm going to do is just going to go. Okay, you can see my browser, right?
Yeah.
Right?
Yes.
Okay, nice. Okay, so now what I'm going to show you is, first of all, how to install Docker. Okay, so very easy. Just go for Docker, and then second, in this case, result. You get here, and then download Docker Desktop. As easy as that. Okay, so depending on your operating system, you will choose one or another, but it should be as simple as that. Okay, it's just an exe file or a DMG file or a package, and then what you're going to have access is to Docker Desktop. Okay, so you're going to need some account here, but don't worry, it's for free. Okay, so it's going to give you a personal license and it's going to be free. And then in Docker Desktop, let me see if I can make it. It's more, well, maybe it's not a good idea. Okay, so in Docker Desktop, you're going to have your containers running and stop. These are my personal containers for my personal projects. And then most importantly, you're going to have images, okay? So here we have different images. So in the slides, we saw you can download public images to use as the foundation of your process, of your projects. For example, I say Node. This is the one that I use to build my Node.js server, or Prometheus, which is what I use, for example, to monitor my server, which are distributed by the organization by itself. But then I have my own custom images, okay, which have containers running, okay? So you can expect this, okay? So you've got your images, which are the seeds or the foundations, or if you want to think, if you have played, for example, gaming emulators, so you've got images are your games, containers are the actual instance of the emulator running that particular game, if you want to think about it in that way. Now, the thing is, okay, how do I start? Let's say I need, for example, an Ubuntu image, because I want to start my project in Ubuntu. Then I would recommend you to go to your browser and then go to Docker Hub. And then Docker Hub is what I mentioned before. It's like the app store for Docker. So you're going to see tons of things here, okay? You can do crazy things with Docker. But usually, you're going to either find it here on the homepage. But the thing that I tend to do is just go here, and then in your case, Ubuntu. And then usually the first one is the one that you should need to use. Okay, so look for this green stamp, Docker official image. I don't think you're going to need anything else. These are okay, but just bear in mind. Okay, so always sort by stars and let's say downloads, and you'll be good to go. Click here, and then you have this command. Okay, so if I go back to the slides, I think I have here. I don't think it's mentioned. Yes, here it is. Okay. I'm going to do it like this. So here we have in the client, so our laptop as well, we've got Docker pull. Docker pull, if we follow the red arrow, is going to call Docker daemon, which is Docker in this case, and then it's going to call, connect to the registry. In this case, it would point to Ubuntu, and then would download the image to our laptop again, and then put it here. Okay, translate it. If I go here to my terminal and I just paste this, whoops, not this one. Let me do something like Docker pull Ubuntu. Yes. It's going to say latest pulling from library Ubuntu, which means I'm downloading this, and then downloaded newer image for Ubuntu latest version. Okay. Now, if I go back to images, you see Ubuntu has appeared here. Okay, so this is how you pull from the register, from the Docker Hub, your Ubuntu or whatever desired image. Okay, and now you are good to use it. Now what you have to do is open, let me go back to the slides so for you to see it. What you have to do now is create a Docker file. So now you have your image, and now you have to specify what do you actually want to do with the image. So from Ubuntu, and then what comes later. Okay. So I'm going to show you my personal project, and I'm not using Ubuntu here, but for example, I'm using Python, which I think. So you could change it, okay? So this is my Python project, so I'm using the Python image because it's on a very lightweight Linux-based image, because I don't care about the Linux distribution, okay? But if you do care about the Linux distribution in this case, you should go for Ubuntu latest in your case. Okay, not gonna do that because it's going to break everything in my case. But line 1 from your name, so your Ubuntu latest, you can find it Ubuntu 2 dots colon latest. Okay, and then specify what do you want. So inside my container, typically you can use /app. There's no problem. There's not going to be any problem there. So workdir /app or workdir /project or whatever, and then copy. What am I copying? So this particular file is located in this hellastisk directory. If I say copy ... means copy hellastisk.py plus the requirement sheet, in this case, into the box, the container that I'm creating. Okay, so copy everything into the current directory. Okay, so this is common. For example, if you do ls dot, you're going to have this. Okay, so you have these kind of things. So it's exactly the same. So dot is a shorthand for this particular folder in which I am right now. Okay. Nothing around here. Okay. So copy this. And then what am I going to do? Before running my actual code, this code has dependencies. Okay. And these dependencies are not there by default because right now we have an empty brand new Linux operating system. So the first thing I'm going to do in this case is to, before anything else, run the command, in this case, to install my requirements. Okay? So it will run my requirements. And then, once it's done, then you can start. Once you click play on the container, command, whatever, Python, u, in this case, -u, hellastisk.py, which is my own file. Okay? Let me try and build this for you because I want to show you. Yeah, this should work. Okay, so if I do docker build, this is the one that you need to use, the command that you need to use. It wasn't like this. Yeah, docker build, I always forget about it. The dot, and then you can see that step by step. I don't know if I can make it bigger or if I will break my computer again. No. Can you see it? I hope so.
Yep.
Okay, good. Okay, so essentially docker build dot means the Docker file is in this particular path. Okay, if it's not in this particular path, it would be docker build my path. Okay, so you have to tell Docker where is it located. Okay, in this case, docker build my path is going to do number 1 from Docker IO library, whatever. So number 1, use this image. Number 2, it's cached because I already did it. So change the directory to app. You're not going to be able to see this because it's not there. It's inside the container. Then copy everything inside, and then finally run pip install whatever, and then exporting to image. Now, if I go to the GUI again, and I go to images, it was called this one. Subscribe hellastisk. Okay. 5 months ago. Let me see if I can just do it. Yeah, okay. So 1 minute ago. Okay, this is what it did. 2 minutes ago. It's this one. Okay, I forgot to add the name. You can add a name, a custom name, but I don't want to overwrite anything that I have here because this is my own project. You can name it. Okay, so this would be with an extra argument. You can add a docker build, whatever, and then name. Okay, so you can add this. But essentially, if I click here, you're going to see lots of weird commands, which in this case, you don't have to care about. Okay, so this is just running inside. But in the end, what you need to test is this doing what I want to do? Yes or no? Yes. In this case, Python, whatever, my file.py. Okay? And then if you want to run a container, there is another one, another command that you can use. It's called Docker run. Okay, I think you could do just click here, run a new container. You can do it from the GUI if you want to do it. Test, for example, GSoC. Let's call it like that. And then volumes are hard drives. Okay, so that is important as well. Volumes are, if you need to store any data, you need a volume. Okay, a volume is because when you destroy a container or you stop a container, all the data that you have been using is going to disappear. Okay, because it's like a one-shot task. Okay, so once it goes down, disappears forever. And then if you want to persist that, you need to say, okay, the contents of this folder inside my container are going to be persisted in my laptop, in my local laptop. So you have to make a distinction between inside the container, inside my laptop, or outside. Same goes for environment variables. You have passwords, API keys, whatever. I wouldn't recommend you to hard code them, because if you're going to distribute this, that is not a good practice. Okay, so you can let them know, look, I have this particular thing in the code, which is going to stand for, or is going to be stored in this file, which is not for distribution. Okay. Anyways, so I'm going to go to run. This is probably going to fail because it's got a lot of dependencies. But right now, if I go to containers, you see a container called test GSoC using the image none in this case, because I forgot to add the name, but our image is running. Okay, and now what I want to show you is that here you should be able to see some output. In this case, it's not going to work. I'm surprised it's still working. You can go to files, and what I want to show you is that, okay, yeah, it died. I'll show you later. Going back to the slides, we mentioned workdir app. Okay, so inside the directory, you've got workdir app, and then if I go back to the container, and I'm going to restart it again, you've got files, and this is the inside of the Linux operating system. I go to app, and then I've got my Docker file, my Python file, and my requirements, which means that the command, the recipe, the Docker file was able to successfully transport my files inside this container. And now the only thing you have to do is, if you want to test something, you can go to exec, and yeah, it's going to break. Let's see if I have some time. I go open a new shell, you see ls, and then you see, for example, cat, whatever. I am inside the container, okay? And you see that everything was okay. Okay, so this is my code, so everything's cool. So Mongo URI, so environment variables. But in case you want to test if everything has landed correctly, or your application is generating your files and storing them in a good way, you can just go to exec and then open a command line. Okay, this is all failing because of my setup. It's part of a more complex system. Okay, but in your simple, let's say, in your monolithic system, it's going to work. Okay, it's not going to die. So here, if you can use the default shell, you can use bash, you can do anything. Okay, so you can just check whatever, including, I don't have this one. No, okay. Yeah, okay. Well, you can run any command, let's say, in order to see how is your container, your operating system working. And let me think. I think I'm done. This is enough for now. And I'm trying to think if I'm forgetting anything. But I can just pass the ball on you. So I would like to know if there's anything that you would like to know, let's say in more detail, anything that you haven't understood, or let's say if there's any doubts. It's probably there's going to be a lot of doubts, but I'd rather you to let me know rather than try to guess them.
Also, we say that you are available wherever they need you. They can ping you, and Mentor Victor will try to help you. But every of you have a specific mentor mentoring your specific project. So Javier, any question?
No, I think
You got
it's
everything. You got everything perfectly.
Well, I've been using Docker for years, but I prefer Docker Compose because it's a way of, well, I hate monolithic systems. So
Let's talk. Could you please explain us? We know, but for the other people, explain what's the difference between both Docker systems.
I don't really know. I just learned how to use Docker Compose.
So Victor, explain what is the difference. What Docker Compose is.
Yeah, okay. Actually, this was part of the presentation. I didn't want to advance too much, but I have a compose file in my setup. So I'm going to show you, and as you see my code, you're going to understand it very easily. So share the screen again, and then go to VS Code, and then you've got. So essentially, what I wanted to understand is this is a very big project, okay, or a fairly big project, okay. I've got a Node.js server, I've got a couple of Python scripts, I've got a database, I have another, what is this? Yeah, again, Python scripts, but a bunch of stuff, okay? Essentially, this is something that is intended to work with dependencies. For example, my Python application is not going to be able to work if the database is not running, okay? If I'm starting to go one by one, trying to see, okay, let's launch my Python application. I may, let's say, make the mistake of not having the database up and running. My database, for example, may fail, may fall down because of whatever reason. And then I don't want to be watching as well if my database is up or down. I want everything to work as I intend. Okay, so all my, in this case, 5 microservices need to work as I tell them, okay? If anything fails, put it up together, put it up, and then one thing has to run in certain order. How do you do that? With Compose, which in turn is, let's say, a set of, it's not a set of Docker files, but it's like a set of recipes. So this is when, for example, but getting back to the kitchen example. So you've got the recipe 1, and then you've got, for example, the recipe 2, which I'm going to show you. Let's say you have the main course, and then you have, where was the Docker file here? And then you have the, what? Okay. Yeah, so you have the main course, and then you have the desserts. So the main course should go before the dessert. How do you know that? How do you specify that? You let it know, okay? So you've got my MongoDB, for example, my database is going to use my custom image, which is sourced, let's say, from my Compose, which I have, and my Docker file, which I have here. I'm going to provide it with some secrets. So my credentials in this case, some volumes, because if this goes down, I don't want to lose my data. And then ports, because I want this to be accessible from the outside, because I'm intending to run this on a server, okay? And then a network, okay? A network is a way to glue these containers together if you're going to have service A called service B, and then there is a database. You have to add a network, okay? So these are more advanced concepts, but essentially what it does is to order, you can do something like that. You let it know. I've got MongoDB here. I used to have this, but it broke. But you have another. So container 1, container 2, and then container 3. And then most importantly, it's got depends on. Okay, so the Node.js server will never start before MongoDB. Until MongoDB in this case is not working, the server is not going to go up. Okay, why? Because it depends on it.
Okay,
so you have.
Let's gonna try, Victor. Excuse me. Let's gonna try to be, because we are short on time as we started late, and we have another streaming at 6 p.m. We have another one in 5 minutes. So, question is, guys, Devanjan, do you have any question for Mentor Victor?
Yeah, just one thing. So, do you recommend using the command line Docker or from graphical user interface?
What I use is normally is I just go into VS Code, and then you can just get yourself a cheat sheet. So Docker cheat sheet. That's what I do. So Docker build whatever. You don't have to learn the command by yourself, but just customize the syntax as you will. And then for the rest of things, you're good to go with the graphical interface. I've been doing it, let's say, a bunch of time, so I know the command line, and I work with a server which has no graphical interface. I use the command line, but still, the graphical interface is good, and you're good to go. You can use whatever you want.
Yeah.
Alejandro, any
I
question?
have a question that if the Docker file works without the Docker Compose file. Okay.
Yeah. Docker Compose is an add-on.
Yeah, it's another level. Just to, if you need to orchestrate more applications, it's an order to specify how those applications have to
Like a
run.
filter that orders the things that you have on the Docker file.
Yeah, exactly.
Okay.
We'll say. Okay. So I asked for the guys at the streaming if they have any question. I don't have any answer, but guys, we have to close because we have another streaming that I hope that you can also join us, because we are going to talk about Gemini and Dart, because this year, just 1 month ago, Google has deprecated the package we used to do work with Flutter for accessing the Gemini API, and mentor Víctor Carreras and mentor Alfredo is going to present us in 3 minutes. So guys, thank you for staying here, and we are going to come back in another session next to this. So bye. Thank you for the presentation, Víctor Perez.
Bye. Thank you.
Bye.
Bye.
Thank you, Victor.
Liquid gas.